Hi everyone. In this class, let us go to understand what is sequential logic circuits. What are sequential logic circuits and how these sequential logic circuits are going to be useful, right? So let us dive into the definition of the sequential logic circuits. That is a sequential logic circuit. Okay, let me just change this pen to highlighter. Okay, a sequential logic circuit is one whose output depends on the present input and the past output, and a memory is required to store the past output and feed back to the input. Okay, sequential logic circuits are logic circuits. Definitely, they are made up of logic gates itself. But unlike combinational logic circuits, what's the difference between combinational logic circuit and that sequential logic circuit, or I can call it as the advancement of sequential logic circuits over combinational logic circuits, is that sequential logic circuits have the capacity of remembering the past output and taking that past output and feeding it back to the input. This is what the extra capacity of the sequential logic circuits makes them special, makes them stand away from the combinational logic circuits. Okay, so that is what he says even in the definition. So clearly observe the definition. What he says, the sequential logic circuit is one whose output depends on the present input and the past output and a memory is definitely required to store the past output and feed the past output through the input or along with the input. So that is what your sequential logic circuits is all about. Okay, so then let me take you people to the block diagram. Block diagram is very simple. You have a combinational logic circuit. Along with this combinational logic circuit, you will definitely have input, output, wherein this output is stored in a place called as memory, and this output stored in memory can definitely be used along with the input, so that the sequential logic circuit has the capacity of processing the present input and even the past output by using a memory unit along with the combination of the different logic gates. Okay, so did you understand this? So next we are going to go towards the further part of your syllabus. The further part of your syllabus is that we have flip-flops. We shall understand flip-flops first. Once we understand the flip-flops, next we will be going towards the this one, what we call them as shift registers. Once we complete the shift registers, then we will be going towards the counters. These are the three main parts in the unit number 5, that is your sequential logic circuits. If you understand flip-flops, if you understand shift registers, and if you understand the counters all put together, that is your unit number 5, that is sequential logic circuits. So before getting into the flip-flops, let us understand what is a flip-flop. What is a flip-flop? A flip-flop is a bistable electronic circuit. It is just a bistable electronic circuit, and it is having two stable states. That is why it is called as bistable electronic circuit. So the given flip-flop is having two stable states. What are the two stable states? One is 0, the other one is 1. You can call the 0 as reset and 1 as set, or even you can call the 0 as low and 1 as high. At the same time, the 0 can be called as reset, 1 can be called as set. This is what the flip-flop is all about. Flip-flop is going to have two stable states. That is why it is called as bistable electronic circuit, bistable digital electronic circuit that has two states, either 0 reset or 1 that is set. Understood? So next we are going to go towards the next slide. Before going to next slide, let me just remove all these markings whatever that I have done. Okay, so let us go to the next slide. Here in the next slide, here we are going to discuss about the clock signal. Okay, we are going to discuss about the clock signal. What do you mean by a clock signal? A clock signal is any particular type of signal that oscillates between high and low. Okay, that oscillates between, that keeps changing between high, low, high, low, high, low. So such type of a signal is what we are going to call it as a clock signal. Okay, it just not oscillates between high and low state, but it can definitely be used to coordinate the actions of a digital electronic circuit further. Okay, so to coordinate the actions of a digital electronic circuit means, if your digital electronic circuit is in low state, it's in a state of low, and you have to make that to go to high, then you can definitely make use of a clock signal. That is what the meaning saying it is used to coordinate the actions of a digital electronic circuit. Okay, it is used to coordinate the actions of a electronic circuit or a circuit. Okay, so that is what your clock signal, this is how your clock signal will look alike. Okay, it will have high, low, high, low, high, low continuously. Understood? So this is what a clock signal is all about. Next we have the types of triggering. Next we have the types of triggering. In this types of triggering, we have two types, that is level triggering, and one more is edge triggering. So let us get into level triggering. Let us try to understand the level triggering. The level triggering is when the active high is maintained at the enable input, then the output is also allowed to change, output is allowed to change by maintaining the high at by maintaining active high at the enable input, and your output level is allowed to change. That is what we are going to call it as level triggering. Understood? So level triggering is when active high is maintained. So all digital, there will be digital electronic circuits. Don't confuse, or don't put all the information onto your brain all at once. Okay, let us understand very easily. So we have a digital electronic circuit. To turn on the digital electronic circuit, we have a switch called as enable switch, or we have an input called as enable input. Okay, what is the function of this enable? Enable enables the given digital electronic circuit to perform, to work. Okay, so now my concept is, I have a electronic circuit, and that circuit is having a enable input. When the enable input, the input at the enable switch or enable input, enable terminal is high, at that time your digital electronic circuit is going to change its state from 0 to 1 or 1 to 0. So that is what I'm going to call it as, this process is what I'm going to call it as level triggering. Either if the input of the input at the enable switch is high and your circuit is going to perform, that is called as positive level triggering. And if the input at the enable is low and then your digital electronic circuit is going to perform, that is called as negative level triggering. That is what he says in the definition below. Okay, let us go through the definition. Okay, so the output of the flip-flop responds to the input changes only when its enable is high. Only when its enable is high, then the output of the flip-flop responds to the input changes. That condition is what I'm going to call it as positive level triggering. Okay, so flip-flop irutte, there will be a flip-flop, and this flip-flop will respond to the input changes. Input changes ge respond ಮಾಡುತ್ತೆ, ಅಂದ್ರೆ output ಕೊಡುತ್ತೆ. ಏನು ಇನ್ಪುಟ್ ಕೊಡ್ತೀವಿ ಅದಕ್ಕೆ ಔಟ್ಪುಟ್ ಕೊಡುತ್ತೆ. ಯಾವಾಗ? when enable is high, when enable is high, ಅವಾಗ ಮಾತ್ರ ಈ ಒಂದು ಕೆಲಸ ನಡೆಯುತ್ತೆ. ಇನ್ಪುಟ್ಸ್ ಕೊಟ್ಟಿರೋಂಥ ಇನ್ಪುಟ್ಸ್ಗೆ ತಕ್ಕನಾದಂಥ ಔಟ್ಪುಟ್ಸ್ ಅನ್ನ ನಮ್ಮ ಒಂದು ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ಕೊಡೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಪಾಸಿಟಿವ್ ಲೆವೆಲ್ ಟ್ರಿಗರಿಂಗ್. Okay, so at the same time negative level triggering antandre ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ, here we have the output of the flip flop responds to the input changes only when its input is low, enable input is low. When the enable input is low, only then the flip flop is going to respond for the whatever the inputs that I'm going to give. Whatever the inputs that I'm going to give to the given flip flop, the flip flop is going to respond to this inputs and give the proper output only when the enable input is low. And that is what I'm going to call it as negative level triggering. Got the point? Right. Let me go to the next slide to make you people understand some more concepts regarding this. Okay, So let me remove all this highlighted mark. Let us go to the edge triggering. Let us understand the edge triggering. So what do you mean by the edge triggering? According to the definition itself, he says here, the output responds to the change in the input only at the positive or negative edge of the clock pulse, not at the level but at the edge. Okay, so if I have a clock pulse like this, the level is what I'm going to call it as level triggering. If during this level your circuit, your flip-flop is going to respond, that is what I call it as level triggering. And at the edge of the clock pulse, if your flip-flop is going to perform, then I'm going to call it as edge triggering. Simple, right? So Ivage, then let us go to understand what is positive edge triggering and negative edge triggering. The positive edge triggering is when the output responds to the changes in the input only at the positive edge of the clock pulse. When I have a clock pulse and this is the positive edge of the clock pulse, this is the positive edge of the clock pulse. During this positive edge of the clock pulse, the flip-flop is going to give the proper outputs for the given inputs given to the flip-flop. Understood? So this concept is what we call it as positive edge triggering. Then let us go to understand what is negative edge triggering. In this negative edge triggering, the output responds to the changes in the input only at the negative edge of the clock pulse. Here we have, this is the positive edge of the clock pulse and this is the negative edge of the clock pulse. Let me just change the color over here. This is the negative edge of the clock pulse. This is the negative edge of the clock pulse. This is the negative edge of the clock pulse. And these clock pulses are given to the enable input of the given flip-flop. Here the funda is, the beauty is, the flip-flop is going to give you the output for the whatever the inputs that you have given to the flip-flop when your enable, okay, the enable input is at the negative edge of the clock pulse. Whenever your enable input is at the negative edge of the clock pulse, then the flip-flop is going to respond for the inputs that is given. That is why it is called as negative edge triggering. Fine. Okay, so let me just not waste much of time and carry you people towards the next concept. The next concept, like so let us go to the next concept. The concept next we are going to discuss is the types of flip-flop. So there are 6 types of flip-flops, okay, that are mentioned in the textbook, but we have only 5 for our syllabus. The first one is your RS flip-flop, clocked RS flip-flop, JK flip-flop, master slave JK flip-flop, D flip-flop and T flip-flop. T flip-flop is not there for syllabus, no need to worry about it. We have only RS, clocked RS, JK, master slave JK flip-flop, D flip-flop for our syllabus to study. So next we shall go about understanding or learning the applications of flip-flops. Okay, so next we have the applications of flip-flops. What are the different applications of flip-flops? It can be used as a memory element. As I already told you, flip-flop has a capacity of storing 1 bit information with it. So that is why it can be definitely used as memory element. It can be used for counting, yes, definitely. It can be used as a delay element, and even it can be used for dividing the frequency divider, and even it can be used as a register. Register is one which registers the given 1 bit data or binary data. Okay, so let me not just confine it as 1 bit data. Register is one which remembers, which accepts and stores the binary data until unless it is retrieved. Understood? So that is what, these are all the applications of your flip-flop. Once you know the different applications of flip-flop, let us go to understand the next flip-flop. Okay, the next topic that we are going to discuss is going to be flip-flops. Okay, so the first flip-flop that we are going to discuss is your clocked RS flip-flop. Once we complete the clocked RS flip-flop, let us go, RS flip-flop, first we are going to discuss RS flip-flop, then we are going to understand clocked RS flip-flop, then we shall go about understanding JK flip-flop, then master slave JK flip-flop, then delay flip-flop. Those are the 5 flip-flops that you people do have for your syllabus. Once we complete these five concepts, we are done with the flip-flops. Then we can definitely go with shift registers. So we have 4 shift registers and we have 3 counters to be discussed in this chapter, so that this chapter is going to carry 12 main questions, and these 12 main questions will give you people 35 marks in your examination. So that is how important this 5th unit is for you people. Without wasting much time, I would like to say, I would like to wind up this video at this part of time, and in the next coming videos we shall discuss about the flip-flops. Okay, I hope all of you people understood all the concept that I have discussed in this video. If you do people have any doubts, please do ask me whenever I am free. Okay, so it's time to say end the video. Okay, I'm going to wind up the video. Thank you.